Hello everybody, I'm Benjamin from STI Innsbruck. I'm working on the GeToVA platform. GeToVA is aiming to support virtual factories in semi-automatic generation and clustering of virtualized intangible assets from real-world semi-structured enterprise and network resources. So it enables the multi-format ontology transformation between various representations of virtualized intangible assets. So this means we are focusing on CVs and on companies, and we provide the ability to extract this information, generate a virtual representation of them, and further we provide the capability of transform them between various formats. And also we provide the search capabilities over these assets. And finally, we provide some clustering capabilities. In this presentation, I will shortly explain how we do this stuff. At the end, I will show some videos, how we extract the data, and then how the transformation works, and some clustering. And if some time is left, I might show a live demo of our dashboard. So, as an overview, as you can see, there are the components or the things we provide. And as you can see, the big part of our application is our REST interface, because our platform is ought to be used via this REST interface. Also, our web interface is using this REST interface. And this REST interface is then providing all the features our platform has, like the clustering, extraction, and transformation. Also, this REST interface is used by the other use cases, which we do for the Fitman project. And so, yeah, let's go. For the extraction, we use a tool called Gate, which is used for text engineering of stuff, and we use it to annotate semi-structured data with text, and then we use this text to extract the data and transform it into various formats. This extraction is shown in the next slide here. So this is just a very short example to get an idea how it is done. We have some unstructured or semi-structured text. For example, in this example, you see a company, like it was this is just HTML, which we downloaded. And then we run this Gate application. And as you can see, the different colors are text or annotations for various properties of this company. And then we use our extractor to extract this data and transform it into RTF or linked USDL. But we also use these annotations, which are done by this Gate tool, to provide sophisticated search capabilities. Like you can search for certain tags and keywords, which I think is quite nice and for later searching. And these features are also basically everything I mentioned here is available via the REST API. So yeah, for example, stuff we can do with this extractor, which we provide, is extraction from HTML pages. For our use case, for example, we extract the data from the Sell to Wales page from LinkedIn. As you can see, here is a LinkedIn company page, or from Aerospace Wales, we extracted some data and we put it into our system. And yeah, or for people, we extracted LinkedIn people profiles, public LinkedIn profiles, and we then provide this as JSON. So which kind of extractors our platform provides? For automatic extraction, which means there's no further processing necessary by the user. We automatically extract data from LinkedIn. There we can extract peoples and companies fully automatically. For our Complex use case, we extract the LED companies from our LED company page. This is also done automatically. We have some extractors for XML database dumps. We were able to extract tenders for sell to whales from the sell to whales page, and companies from the aerospace whales forums. And for the semi-automatically extraction, which requires you to use Gate, it is possible to extract data from CVs, the resumes. This is the main focus we put on when it comes to extraction using Gate. But it's also usable to extract companies. And yeah, Gate is best fit for extracting it from data like text or HTML or XML or basically some text-based format. And yeah, also the data we extract is then stored as an ontology. So to make this data useful and be usable as widespread as possible, we provide transformation capabilities. So most of our data is available as JSON, JSON-LD, XML, RTF. And with RTF, we mean various ontologies based on RTF. So for the example, for the CV transformation, this is done as follows. Since we provide support for various formats, it's enough to add the CV in any of the supported formats into our system by using the RESTful API. And then we store it with an ID, which then can be used later on to access this asset. And you can access this asset, and if this in a specific format, and if this format is not existing, our system will create it using the Europass format handler. I will come to this, and or a converter. The Europass format is a format made by the EU Union. It's some common format which is useful to have some unifying format for people. You probably saw this one before. And but they also provide a REST API which we use at some point to create XML out of our JSON which we create. So as you can see, as I mentioned before, there's this Europass format handler. So if you have a CV in any of these formats, which you can see in this picture in green, then you can use the Europass format handler to transform between each of those marked formats. And there's this converter. The converter is transforming between different ontologies. So we have a base ontology, which is basically just a transformation from the JSON one-to-one to RTF. So there's not much semantic meaning behind this. But on this base format, we have some sort of a common ground where we can start to create meaningful ontologies by transforming it from the base format. Also, it's useful if you have a CV in a certain ontological format, you can transform it back to this base format and then transform it to another ontology. Yes. So yeah, and to transform JSON format to RTF, like I mentioned, we call it base RTF. We use JSON-LD. JSON-LD, for those who don't know, is basically just an extension to JSON, which uses semantic annotations. So the JSON-LD is basically like RTF, and it can be transformed easily to RTF. There are many libraries to do this. Yeah, we also check if we extract company people profiles, whether they are valid with the Europass format, because yeah, it is done by using a JSON schema which is provided by Europass. This is also necessary for this transformation to work. So yeah, here you can see, for example, a JSON file of a people profile. So this is just the plain JSON. And what we do is we just add this context, how it's called. This is just the annotation which basically makes normal JSON to be JSON ID. And then you can just transform it instantly to RTF, or in this case we call it the base RTF. And from this kind of format you can transform it to other ontologies using our converter. And to do so we use Sparkle constructs. So for people who don't know, Sparkle is the standard query language for RTF or for triple stores in general. And Sparkle constructs are like Sparkle queries, but they're used to transform between RTF triples to other RTF triples. So we used for this for our GeToVA platform we use the resume ontology, which is a ontology which aims at providing semantics for resume or CV descriptions like academic experiences, skills, and all the stuff, or language capabilities of people, all the stuff which is needed to describe a CV. And yeah, there was one problem that it's not fully compatible with VAaaS format. So some data can be lost by doing transformation, but I think it's still working quite well. So yeah, again the Sparkle constructs which we are using. So this is an example of the Sparkle construct. As you can see, you have here, on the top you see what you want to create, like a person name is a person, or no, person name is has a first name or and a last name or surname, and this is what we want to create. And on the bottom we have the original file, or the original triples which we want to transform, and use this kind of techniques basically to transform between arbitrary ontologies. And it's also possible to add your own Sparkle constructs. So if you want to transform to your own ontology, all you need to do is add your own Sparkle construct rule into our system, and then you can use our system to transform it. So yeah, this is, for example, what's happening. We have our base RTF on top, and then we create the resume format on bottom. And this top one is based on the VAaaS format, and the bottom one is based then on the resume ontology. We provide clustering. So if you extract some assets, you can cluster them, which looks like this. We have a visualization in our platform, and we use web time frequencies, and all the data is also available as JSON. Also, like all the numbers behind it are available as a pretty huge JSON file with all the information you would need for the analysis of the clustering. So yeah, finally we have a dashboard, which is basically just our graphical interface for our REST interface. So yeah, there you can play around with it. It's accessible at Fitman STI 2.at. So if you want to check it out, you can try it there. Yeah, and again with this REST API, maybe just to give you an idea, like you can, to scrape for LinkedIn profiles, you can just call get scrape LinkedIn and provide a URL to a public LinkedIn profile, and then you will get the JSON returned from this profile. Or if you want to fetch an LED company, you can also just provide the link to the LED company, and it will get fetched, and you get redirected to the extracted company, and you get the JSON, of course, back. Yeah, some other comments. Yeah, finally to the technical details. The front end is running on Ruby on Rails. Also, the REST API is running on Rails. We use a GitHub library, Ruby RTF, to handle all the semantics, like the transformation or the Sparkle constructs. And we have also some normal Sparkle queries. For the front end, we use a SQLite free database. The clustering is based on the Mahoo Apache library. And the visualization uses D3.js, so a JavaScript library for the visualization of the clustering. The knowledge extraction is, as I mentioned, done by the Gate tool. For the searching, which I was barely mentioned, is done using an Elasticsearch server. So there's this Elasticsearch server provides a rather huge RESTful API where you can do all kind of stuff. Finally, for deployment and to run all the stuff, we use Docker or Docker Compose. So this is some kind of lightweight virtual machine, basically. So this should make it very easy to get this stuff running on your computer. All you need to do is to get our source code, which has this Docker Compose file in it. You have to install Docker. It's all in our instructions. And then you can just run our application with one command. So it should be easy to try it out if you want to. And for production, we use an Apache server with Passenger on it. Yeah, so now I will show you a short video. So maybe it's then easier to understand what we are doing. See. Yeah, so this is the Gate tool. For example, you see a CV or resume, which I just picked up from somewhere I just was Googling for some resumes I could use. And then I put it into the Gate tool, which is using its pipeline to extract and to pre-process the data. Here on the right, you can select the text you want to see. And as you can see, Gate already automatically annotated some stuff. So this can also already be extracted into our system. But since this is a rather unstructured text, we have to manually add some annotations. So like here, I mark this kind of passage and I add this description, this work text. So now the system knows that this paragraph is about the work of this person. This part is about the description of the person. And I have to continue doing so for the next paragraph. So again, I mark it as a description. In this paragraph, I mark as scanner work and the work has the following description. So I add annotation description. Final one. And here you can see in the allocation paragraph, Gate already I was able to annotate some of the organizations, so I don't have to do this. But sometimes Gate is not completely correct about some annotations, so it's not fully annotating the whole name of the organization, so I might have to manually extend this. Yes, here I basically do the same stuff I did before, but for education instead of work. Now, when I'm done with the annotation or the manually annotation, I can extract it as an XML. Use the extractor to extract the data. In the current system, this is automatically uploaded to the server. But maybe here to show also show the front end. You could, for example, just take this RTF which we created here. I think it's resume ontology RTF. And now create a new individual or new person on our front end just by passing the format. Like it's we have to switch the format. No, it's JSON actually. And give it the name, and now it's created. So we created a JSON for this person, and now we can select the other formats. And you see it's loading a bit. This is because it's generating the format. Like here, it's creating the RTF out of the JSON. And here the JSON LD. So this is now in our system. And yeah, here we see how for example, you can extract companies out of HTML. This is a downloaded LinkedIn company HTML. So you just add the HTML here and it's extracted. Like here we extract RTF and linked USDL from the company data. And I skipped a part. I did not manually add them all. There's also some scripts available to speed up this, so I did not show it. But here I extracted several companies, and then you can just run the clustering. Oh, sorry, I skipped some parts. It takes some time sometimes, and then now here, those are not that many companies, but I think you get the idea how it's done. And here's all this extra information which you can request via the REST API, so you get a JSON here. Okay. Maybe really quickly, this is the same thing done before, but for companies. Here I add multiple HTML files at once. Like here, I import a whole folder full of HTML files of companies. I skip forward because I'm running out of time. Here I cannot see, but here I import this gate word list and I run it now. And then you can see that Gate will automatically, or has already automatically marked all this kind of information inside this or in this semi-structured HTML file. So now if I select them on the side, you can see that they're highlighted. So I can use Gate in this case to just check whether my automatic extraction was good or bad, and I can manually adjust it. And yeah, once I fixed some errors which the extractor might do, and here you can see the content of this company and the link to USDL. And here create another cluster. Yeah, that's it. So thank you for your time. It was nice to present to you. If there are any questions, I'm ready for them.